guys, my name is Wang, and right now I'm a senior in college majoring in biology. So today I'll be talking to you about my most interesting research done at Penn, which is my project on how social and environmental influences impact microbial diversity in rhesus macaques. So a little overview about my project. I wanted to talk about the role of skin microbes in mediating human health and disease, and that's something that has been shown in literature throughout the years. However, there is minimal literature on how the skin microbes, social behavior, and environmental effects all kind of combine together to demonstrate some kind of effect in non-human primates, specifically in our case, in rhesus macaques that live on the island of Cayo Santiago, Puerto Rico. So in our research sample, we examined 93 animals. They're free-ranging and they mate randomly on this island. And they also self-organize into these matrilineal hierarchies. And there's a total of 1,600 primates that live on this island. And for our project, we had a total of 394 hours of observation for an average of 4.24 hours per animal. So just to go over our measures for the project, so we wanted to look at social behaviors, which we measured through grooming behaviors and dominance hierarchies. And for the shifting environment, we looked at the year and month of sample collections. So when it says patterns of affiliation, we measured that through grooming behaviors. And then for the skin microbiome, we looked at alpha and beta diversity, and we did this using 16S rRNA. So for this project, we have a total of 2 hypotheses. So one is that animals from the same social group would have, and within the same social status, so they're ranked into like high, medium, and low social statuses, would have more similar microbes. So they would display like a very similar alpha and beta diversity. And the second hypothesis is that animals would show seasonal differences. So an animal trapped in January of one year would show very different composition than an animal trapped in like June of another year. So for the first thing we did was that we did a Bray-Curtis dissimilarity plot to measure the level of grooming. And essentially, Bray-Curtis is just a measure of beta diversity. So how different is one set of sample from another set of samples. So it's a very comparative analysis. And if you have a measure of, if you look at the y-axis, it's a measure from 0 to 1. And a measure of 0 means that it's the exact same abundances, and a measure of 1 means that it's completely different. So if you look at, we basically grouped the level of grooming into different quartiles, so 4 quartiles, and then we looked at the pairwise dissimilarity for the microbe diversity based on the beta measure. And as you can see, you really don't see a level of association between level of grooming here and pairwise dissimilarity, because if you look at, this is a violin plot that basically shows the spread of the data. And if you look at this, the line here is the median, and the median for each one is roughly on the 0.5 measure. So basically this is like no association. And we see this no association is evident in this, which is with the 2013 animals, and also here in the 2015 animals. And all these animals are taken from group F, so they're in the same social group. So we control for diet, social group, sex, basically everything except for grooming affiliation here. And another measure of social behavior that we're interested in these animals, aside from affiliated behaviors, which is measured by grooming, is dominance rank. So as I said, the animals are organized into high, medium, and low dominance rank. And then also there's one animal that's like we did not categorize that animal. So if you look at this is a measure of alpha diversity, which is essentially just like how different these microbes are in one individual animal. So not really doing a comparative analysis between two groups. And you see, very similar compared to the grooming, which is this, there's no association. So we calculated a p-value, and the p-value was greater than 0.05, our alpha value, so that basically means that our findings are not significant. So we see that for both measures of social behavior, we did not find a significant association between the social behavior and the microbial diversity. So we also, in addition to alpha diversity, looked at beta diversity for dominance rank as well, and beta diversity is when you compare two groups together. So in here we compared all three measures of dominance rank to the high group, and we see no association. Same with medium, no association, and then same with low, also no association. So if we look at the results here and you look at the p-value, we see that they're all greater than 0.5, which is our alpha level, again confirming that there's no significant associations between our two measures. However, the thing that we found was interesting is that there is a strong association for trap year and month. So this is basically when the season and the time that these animals are trapped and their samples collected. So we look at alpha diversity for this measure, and we actually see a very significant association. So if you look at them, if you look at the mean values, they're all over the place. So, for example, an animal trapped in January of 2014 has a very different alpha diversity measure of their skin microbe than an animal trapped in December of 2015. So this is very intriguing for us. So in conclusion, we see a very surprising thing in that we expect social behavior to influence your microbial diversity, in that if you're interacting more with each other, we expect to see that you would transmit bacteria among animals, but we don't actually see that here. However, we do see dramatic differences across trap seasons, namely from 2013 to 2015, which suggests that maybe environmental influences play a greater role in mediating the skin microbial diversity in these rhesus macaque animals than social behaviors. And this could give us more insight in how environmental organisms can influence an organism's health in general. So thank you so much, and this concludes my presentation.